Ask a chatbot for cheap flights to Tokyo, and it writes you advice. Try comparison sites. Be flexible with your dates. Ask an agent, and something different happens. It searches real flight data, compares the prices it actually found, and books the one that fits your rules. Same kind of model underneath, the same next word predictor. The difference is not a bigger brain. The difference is a loop and a set of tools. And that small difference is why every tech company is suddenly racing to build agents. Over the next few minutes, you will watch a plain text predictor get hands, get a memory, learn to check its own work, and get a leash for the moments when things go wrong. To see why any of that is needed, start with what the model can do on its own, which is less than you might think. On its own, a language model is sealed. Text goes in through one slot, text comes out through another slot, and that is the entire interface. It cannot open a browser. It cannot click a button. It cannot run the code it just wrote. And it cannot remember what you told it yesterday, because nothing persists between conversations. So when a plain chatbot says, "I have booked your flight," no booking happened anywhere. It produced the words a helpful assistant would say, because words are the only thing it can produce. That sounds like a dead end, but it hides an opening. The model is very good at reading text, and very good at writing text in any format you ask for. So what if some of that text were never meant for you? What if the model could write a message that a piece of software reads instead and acts on? That is exactly what a tool is. A tool starts as a menu. Before the conversation begins, the system hands the model a list of actions it is allowed to request. Search the web, run this code, read that file. Each entry says what the tool does and what inputs it needs. Now give the model a job. Find a flight from Chicago to Tokyo under $900. Instead of answering you, the model writes a small structured request. Tool, flight search. Origin, Chicago. Destination, Tokyo. Maximum price, $900. And here's the part people get wrong. The model does not execute anything. It only wrote text in a precise format. The system around the model, called the harness, reads that request, checks it against the menu, and runs the real search on real servers. The results come back as text, and text is the one thing the model handles well. The model proposes. The harness executes. Keep that division of labor in mind, because it is about to become a loop. Watch one full turn of the loop. The model proposes an action, run the flight search. The harness executes it and gets back 3 real options. Then the crucial step. Those results are pasted into the context right after the model's request, as if they were the next part of the conversation. The model reads its own request and the fresh results and decides what to do next. It could compare the 3 fares. It could search again with different dates. Here, one fare fits the rules, so it proposes the booking. Act, observe, decide, then act again. Around and around, one tool call at a time, until the model decides the job is done and writes a plain answer to you instead of another request. That loop is the whole definition of an agent. And notice that the model never got smarter between steps. It just sees more, because every result lands in its context. For a small errand, that is enough. For a real project, the agent needs a plan. Give an agent a big job, like planning a full conference trip, and a good one does not start booking things at random. Its first action is to write a checklist. Find a flight under $900. Book a hotel near the venue. Reserve an airport train. Build a day-by-day schedule. That plan is not stored in some special planning circuit. It is plain text sitting in the context, where the model rereads it on every turn of the loop. Then the agent works down the list one item at a time, marking each item done, and the check marks tell it what to pick up next. When a step fails, say every hotel near the venue is full, it can revise the plan right there in the text, and later turns follow the new version. A plan the model can reread beats a plan it would have to remember. And that points straight at the agent's real weakness, memory. An agent's working memory is its context window, the running text of everything so far, and that window is finite. Every tool result, every plan revision, every page it reads takes up room. On a long job, the window fills, and the oldest details fall out of reach. So long-running agents do what people do. They take notes. A notes file on disk holds the booking confirmation number, the decisions already made, the dead ends already tried. A short summary compresses 40 tool calls into 5 lines. Next session, the agent's first move is to read its own notes, and the facts that matter are back in the window without the thousands of words that produce them. Nothing mystical is happening. Files and summaries, written by the model, through the same tools as everything else. So the agent can act, plan, and remember. One habit still separates a slick demo from an agent you can trust. That habit is checking. A weak agent writes code, declares success, and moves on. A strong agent runs the code. Suppose the job is fixing a bug. The agent edits the file, and its very next action is to run the tests. The result comes back. One test failed. That failure is not a disaster. It is exactly the information the next turn needs, sitting in the context like any other tool result. The agent reads the error, tries a different fix, runs the tests again, and this time they pass. Only now does it report the job done. The same pattern works outside code. Open the file you just wrote and reread it. Compare the booking against what was asked. Verification turns each mistake into one more turn of the loop, instead of a wrong answer delivered with total confidence. But loops that keep going until they succeed have a failure mode of their own. Everything the agent does becomes context for what it does next, and that cuts both ways. One wrong step, a misread price, a bad assumption, feeds into every step after it. Plans drift as the loop grinds on. And a loop with no exit can spin forever, retrying the same broken action, burning money on every turn. That is why real agents run inside guardrails. A budget, at most 20 tool calls, at most $10, then stop and report back. A sandbox, code runs in a sealed workspace, where a bad command cannot touch your real files. And approval gates for anything hard to undo. The agent lines up the flight booking, then it stops and asks a human before any money moves. The gate does not make the agent smarter. It makes the cost of a mistake small. All of this might sound futuristic. It is not. You have probably used an agent this week. Coding assistants are agents. They open a real code base, edit files, run the tests, read the failures, and try again. Exactly the loop you just watched. Research modes are agents. Ask a hard question, and the system searches, reads what it found, and searches again with sharper queries, sometimes for minutes, before writing the answer. And computer use models are agents whose tool is a screen. They look at a screenshot, propose a click or a keystroke, the harness performs it, and a fresh screenshot comes back as the observation. 3 different jobs, one identical shape. Propose, execute, observe, decide. Once you can see that shape, you can spot an agent anywhere. And it means the whole story fits in one line. An agent is a model, plus tools, plus a loop, plus checks. The model proposes each action as text. The tools let the harness turn that text into real searches, real edits, real bookings. The loop feeds every result back in, so each decision is better informed than the last. And the checks, the tests, budgets, and approval gates catch the failures that a text predictor will sometimes produce. The chatbot could only tell you how. The agent finds out, verifies, and finishes the job. And everything you watch still flows through one narrow channel. The context window, the model's only working memory, holding the plan, the notes, and every result. How big is that window really? And where did the mountain of text that trained the model come from in the first place? That is next time.